independently exists. It requires H2. But helium atom, He, that independently exists. So it is an atom, it is a molecule. And that molecule consists only one atom. For that reason, those are called monomolecular atom. And atomic spectra is same as molecular spectra. Right? If you study the energy levels of atom and molecular is same in case of monomolecular substance. And in HCl, R2, RH2, these are diatomic molecules. Diatomic HCl, RH2. They consist two atoms. If I have two atoms are same, homonuclear diatomic molecules. If they are different, heteronuclear diatomic molecules. And we got triatomic molecules. They consist three, for example, carbon dioxide, O3. Right? They consist of three atoms. Right? Then we got 4 atoms, 5 atoms, 6 atoms. There is many atoms will be making one molecule. Right? That is the difference between atom and molecule. And if you see the importance of, first let me complete this because you have already studied ionic bond, how ionic bond is formed. These primary bonds are formed because of the valency electron. There may be a transfer of valency electrons or there may be sharing of the valency electrons. Ionic bond is because of not sharing, because of transfer of valency bond. One is for example, H has got one atom. One electron outside its atom. Right? This is consists nucleus of H, one electron. But if that cell is not closed there, what is the capacity of that first orbit there? 2 electrons is the capacity. Our cell closure occurs for the first orbit if there are 2 electrons, but there is only 1 electron. For that reason, H is eager to give that electron to any nearby atoms. And if you come to chlorine has got 7 electrons. But cell closure, octane code. When there are 8 electrons in the outermost orbit, that is chemically inherent. It will not take place easily in the chemical reaction. Always it wants to make 8 electrons in the outermost orbit. Right? It is eager to give this and it is eager to accept that. Right? It wants to make 8 electrons. It don't want this electron to be in its orbit. For that reason, what happens? A natural bonding is formed because this is eager to give, this is eager to accept. So H and Cl gets attracted and this electron is transferred to this. If electron is there on this nucleus, it is neutral because positive charge is balanced by negative. But this electron, when it transferred to this becomes H plus. And when the electron is coming on to this, if 7 electrons is there, charge is balanced. But when this electron is coming on this, Cl becomes negative. Because the electron is transferred, a valence electron is transferred from one atom to the other. That leads to a bonding. One end is positive, another end is negative, and that type of bonding is called ionic bond. Right? And ionic bonds usually they are very strong compared to other two bonds. Right? Let's see here. We are seeing the ionic bond. And they usually have higher metallic these things. They dissolve in polar solvent. Polar solvent means there are two types of solvents in which substance are dissolved. Polar water is a polar solvent. Non-polar solvents are benzene, toluene. They are also dissolved many substances, but they are non-polar solvents. Water is a polar solvent, and ionic bond compounds dissolve in polar solvents like water. And when you come to covalent bond, there is the sharing of the electrons. For example, if you take hydrogen, one electron, another hydrogen, one electron. Now they share this. If we move like this, it moves like this, or it appears two electrons on this, two electrons on that side because of the movement. Or if you take germanium, in outermost orbit, where those are called valence electrons, you will see this. Right? Like this goes, like this goes, like this goes. Four, but they share four neighboring atoms and all are satisfied. And there is sharing of the valence electrons, and that is called covalent bond. And some covalent bonds are stronger. Usually they are less strong compared to ionic, but there is exception. Some covalent bonds are stronger than ionic bonds, some are very weak. Usually they are less strong compared to ionic bond, but there are some exceptions where it becomes very strong, like in diamond it is very strong covalent bond. But in graphite we don't see such shape. That is also carbon, that is also carbon. Diamond is also carbon, graphite is also carbon. But there the structure, for example, carbon 60 carbon atoms will make a huge structure which is very hardest to keep. That is covalent bond, and they dissolve in polar or non-polar solvents like benzene. This is about covalent. And metallic bonding takes place in metals. In metals, usually what happens? Metals solids, and in solids the atom are arranged in regular pattern, regular periodic pattern. They take equidistance, and everywhere it looks the same. And the line of array of atoms is called lattice, and that is the structure of solid. So usually these atoms, for example, you take metals, on the outermost orbit, 2 or 3 electrons are there in the valence band, and they are ready to come out from the atom. For that reason, what happens? It donates its valence electrons. The valence electrons come out of this atom. Right? They are very free in metals. There is no, forbidden gap is almost zero. If the electron is in the last bench, that is called valence electron. If it is out of the class, it is not binded to this, then that is called free electron. Free electron means it is not binded to any of the class. Right? In metals, class is very, teacher is not strict. The last bench student can jump from last bench to outside or outside to last bench. He does not require any energy. Very easily can go and he can come. That is the metal. Right? So what happens? Usually what happens? picture. Students are moving in the corridor. They are like metals, right? And they can easily conduct electricity, thermal energy. For that reason, they are good conductor of heat and electricity. And when these atom loses the electron, what happens? It becomes positively charged, but it will not move. It tightly bound. These are the positive ions. Usually in metals, all atoms or ion becomes positive ions because electrons are freely moving. And that becomes an electron cloud, group of students moving in the corridor. Right? And it consists of electrons negatively charged, right? And it is poses some attractive force with the positive charge. See, an electron cloud is there. It is attracted by this, it is attracted by this, it is attracted by this, it is attracted by this. Then there is a bond formation. Attractive force is nothing but bond, which holds them together. Bond means there is no thread tied to two atoms, nothing. It is only the force which keeps them together is known as bond. Force, attractive force which keeps, right? You are for the same class, coming for the same town or village to the college, automatically there is a bonding. You come together, you go together, right? Such. There is no rope connecting you and your friend, right? It is not tied, but indirectly there is a connection. So that is bond actually. So there is a bond in between these negative cloud with the positive ions, and that is called metallic bond. And usually they are less stronger than this, but the metallic bond compounds or metals are good conductor of heat and electricity because of the plenty of free electrons available in the metals. And when you come to hydrogen bond or van der Waals bond, you are seeing a weak attractive force between one positive end of the molecule with the other negative end of the molecule. There is one molecule, there is another one, but they are polarized. Polarized means one positive end on one side, negative end on the other side. It acts like a dipole. One positive end, another negative. For example, water molecule. If you take water molecule H2O, it is like this. Right? This one electron of hydrogen is O2 is minus 2 negative because one electron comes here, another electron comes here. This negative means most of the time these electrons of hydrogen are available on oxygen atom. They spend more time on oxygen atom. For that reason, this end appears negative and this end appears positive. So this is of this kind. This is negative end, this is positive end. This negative end attracts another hydrogen atom. Another molecule is like this. This is positive. And automatically there is some attractive force between this and this. Similarly, there is another oxygen. Here one hydrogen. So there is some weak force is established from one negative end of one molecule to the positive end of the other molecule. And such a type of bonding is called hydrogen bond. And these are called molecular bonds. These are atomic bonds. Primary bonds are between atoms. But secondary bonds are between molecules. So this one water molecule is attracted by another water molecule. Whereas here one atom and atom or atom. But here it is between one molecule and with the another molecule. This is a hydrogen bond, right? And when you come to van der Waals bond, you are seeing for the noble gases. very weaker than hydrogen bond. Weaker than hydrogen bond. What happens? Usually in a noble gas atoms, for example, you will take helium or neon. This atom is like this. This is the electrons, right? Helium is 2He4, right? Right? How many electrons are there? This gives the number of protons, that is equal to number of electrons. So it consists of 2 electrons. And there are 2 protons. Positive charge in the nucleus, negative charge in the electrons. The positive center, the center of positive charges is coinciding with the center of negative charges. Center of positive charge, if it coincides with the center of negative charge, the atom looks electrically neutral, right? Like this is, if you test the charge for this is neutral, because the positives, it consists of positive charge, negative charge, but it is neutral because equal number of positive and equal number of negative charges. The positive center coincides with the negative center. If I make that different, if I make positive center and negative center different, then it becomes, if I place one more helium atom nearby, what happens? The positive center and negative center now becomes different. When these electrons are coming here, right? When electrons are coming here, and this becomes negative and these electrons moving far, right? These electrons are coming on this side and the protons are on this side. Only the shape is changing. Electrons are coming this way. This is positive and this is negative. Equal charges, but one on the other side and the other charge on the other side. And this will make it to attract. Right? Earlier there is positive center, negative center coincided, but now positive center moved on this side, negative center moved on this side, and this negative center attracts the positive center of the other. And in noble gas you find such type of shift in the positive and negative center of the atoms will attract one atom with the other, and this is called van der Waals forces. A weak force is making them attract one another, and those are called van der Waals forces. And they are even weaker than the hydrogen bond. Right? That is the R type of bonds that you are seeing in the metal. That was there in the syllabus. We mentioned chemical bond, what type of bonds we have. Chemical bonds, we got ionic, covalent, metallic. These are atomic bonds. But primary bonds stronger than the secondary bonds, hydrogen bond and metallic bond. I have given notes in that PPT on the posted in the group. You know van der Waals bond. We also mentioned van der Waals bond in the syllabus. Okay, this is about bonding with the chemical substances. Now we come to the importance of studying spectra. Why we study spectra? Always we are doing spectrometer experiment. Maybe you are not recognized the importance of this spectra. What is the importance of studying the spectra of an atom, spectra of a substance? Why you are studying the mercury spectra? Why you are studying hydrogen why you are studying spectroscopy? That importance means light is a powerful source of information. It carries information. How you are able to recognize my color, my shape, my eyes, my hair, everything? How you are able to do that? Because of the light I reflect, you are catching that light, and that gives everything about me, outer appearance. Okay. That is the source of information. The light that coming from the object gives the information of the object. That is the idea. See, we have not gone to any galaxy, we have not gone to any star, but we are able to say the size, even not gone to sun. But we are able to say how much hydrogen it contains, how much helium it contains, at what rate it is burning, and what is the temperature at the interior core and the outer. How you are able to say stars? Because you are getting light from that. By seeing the spectrum, by looking the light coming from the star, we are able to say the size of the star, the mass of the star, the structure, its content, its temperature, everything about the star, and whether it is coming to us or moving away. Red shift, blue shift, red shift is going away, blue shift is coming, whether it is approaching or at what rate it is approaching, everything you are able to say only by observing the light. Right? For that reason, light is called a powerful source of information. That is the only information that gives about the idea of the celestial bodies, the objects in the sky. So, for that reason, the study of spectrum is very important. Right? Study that light is not only visible light. If I am looking from your eye, then it is visible light. Visible light, your eye recognizes only part of the electron. Light is electromagnetic wave. Light means all this. On this side we got gamma rays, X-rays, ultraviolet, visible, infrared, microwave, radio. All this is electromagnetic wave that usually generally is light. But this part, the visible 4000 angstrom to 8000 angstrom. This is called visible band. Okay, visible band. That our eye is able to see only that part of the electromagnetic wave, and that is called visible light. And this is invisible light, invisible electromagnetic. But everything carries information. Right? When you are looking at the telescope, you are only seeing the visible light. But that is not only required. All of the object is sending radio waves. We have radio telescope. Right? Radio telescope, it catches radio waves coming from the distant object. Right? Very big antennas are to catch radio waves, microwaves, ultraviolet, right? So, like we have a spectrometer in a lab where you are seeing only visible light. For example, if you put hydrogen, you are missing so many lights. You are only seeing H alpha, H beta, H gamma, H delta. Only 4 lights in the visible region, and that is called gamma series. But you are missing Lyman series, Pound series, bracket series, all these. They are also giving information. right? That information you are missing. Then you have to put a photographic plate that will expose those lines are visible. So then only you can see the energy levels, the energy that electron can have in that atom. What happens usually when your light falls on material? It excites the molecule. It takes the molecule to the excited state, from ground state to higher energy excited state. Right? Okay. And it takes this much energy. If this supplied energy is equal to this much energy, then only it takes. Otherwise, it will not take. A photon is absorbed. If it is able to go to that, not to intermediate state, there is no state existing in between. For hydrogen, from first n is equal to 1 to it has to go to n is equal to 2. There is no in between state. That is quantized. We say quantized means this level, if not this level, to this level only, not in between. It will not go to Krishna to it goes this or that, not in between. Okay. That way it can go to the excited state. Right? So this light is absorbed. And if you are looking outside, this light is missing. If you are looking the light coming from this, you are making light to go onto the substance, but that light is absorbed and you are missing this. If you are giving white light and only if this light energy is, for example, if you take some sodium, if you are sending white light consists of 5890, 5896 and strong lines also. It consists also yellow. Yellow means a yellow of mercury is a different, yellow of sodium is a different. There are several yellows. Each atom element has its own particular lines. Sodium 5890